Good morning. My name is Chaitanya. Here I'm presenting my paper ID 40 with titles Agent AI for real-time resilience and adaptive fraud detections in digital payment systems. Here the outline of the paper consists of introduction method, results and discussion, conclusion. And coming to the digital transformation in financial systems, it comes with the rapid digital transformation of the financial sector and its revolution is money movement worldwide. And it generally nowadays the digital payment is being defined in terms of mobile wallets, online banking, P2P apps, and e-commerce tools, and it being dominates the global transactions. These innovations innovations provide unmatching, convincing, and faster transactions, improved customer experience and inclusion, secured access to financial services for underserved communities. And it also introduced new security and privacy risks, and it comes with cyber criminals exploit system vulnerabilities through identity theft, money laundering, and automated AI fraud detections. And the need for this financial system is with respect to adaptive fraud detection system that can evaluate adversarial strategies. And here the limitations comes with respect to rule-based and heuristic detection frameworks, which is increasing ineffectively. And the challenges faced could be the dependence on statistic thresholds and high false positivities, failures to detect zero-day attacks, and adaptive threats. Impact on financial institutions comes with loss of customer trust, increasing option cost, and poor scalability. And this is a rule-based to intelligent learning-based protection. And the rise of AI-driven and agentic AI approaches comes with respect to machine learning, deep learning, and graphical networks. And these generally analyzes large-scale transactions in real time, detect nonlinear correlations and substantial anomalies, and continuously learn a value. And then we are going with Agentic AI. This Agentic AI is autonomous and goal-driven and self-optimizes the intelligent systems. And here the precision region and adopts automatically, which generally reduces the fraud detections and uses contextual awareness with respect to behavior, location, and time, and the device what we are using. And it employs ensemble decision making, the statistical deep and knowledge graph methods. And generally, these agentic AI reduces the false alarm and improves the resilience against evolving fraud statistics. And here, the hybrid GNN transformation framework and dynamic synthetic oversampling the reinforcement feedback generally comes with respect to core framework computation both. And here these combined implementation has a performance highlights with accuracy 99%, precision 91.84%, equal 89.12%, and low false positivity and superior adaptability to an evolving fraud behavior. And this generally comes with adaptability and feature enhancements in terms of cross-border and multi-currency detection and explainable AI integration and adversarial training. And just the general summary of these particular enhancement comes with SDK powered hybrid framework where it achieves scalability, robustness, and reliable real-time adaptabilities, and makes the things autonomous, intelligent-driven financial security and systems. And this ODO framework comes with the framework components of GNN transformation and dynamic synthetic oversampling with reinforcement, and the methodology works with respect to data collection, pre-processing, and the proposed method rebalancing, hybrid GNN transformation training and evaluation. And the datasets we are using is Kaggle database IEEE size fraud detection with around 284,000. It's recent transactions with only 0.1 labeled as fraudulent. And attributes include timestamp, merchant ID, card holder, and relational features. And data processing and graphical constructions comes with goals, that is data quality and structure for graph and sequential learning. And this pre-processing generally goes the data collection and normalization. Graph and sequential formation comes with the transaction graphing and sequential ordering. And dynamic synthetic oversampling with reinforcement feedback comes with challenges and solutions. Here, the reinforcement feedback is being updated with the reward functions and the threshold management related adjustment factors where the fraudulent as well as DKI adaptively trains and loads the things with respect to that particular parameter. And the advantage of the existing method is it can be dynamically use model precision with respect to real feedback and reward functions. And the steps of genome transformation model architecture comes with the graphical neural network learning parameters relationship, and it comes with the model transformation order, that is authentication this particular equation, and function layer and policy engine that combines GNN structural insights and transform temporal regions, and its adaptive thresholding dynamics turns sensitivity to evolving frauds. Training sets, it comes with data set splitting of 80% training and 20% of testing, and this rebalanced minority class functions and joins GNN transformations with policy based threshold turning and baseline compared with respect to MLP, LSTM, GCN, SMOD, random over sampling, and evaluation method comes with precision, accuracy, precision, and F1 scores. And the performance evaluation overview comes with respect to random forest neural networks and XGBoost Lite BGM. We can see the proposed one giving the better performance with respect to the existing ones. And here the impact of DSORF on class balances is being illustrated in the graph, and that you can see the proposed method is giving better performance with existing uh, methods in terms of bar evaluations. Comparison analysis of ROC and PR curves, and here you can see that high AUC and balanced PR indicates excellent trade-offs and superior fraud detection at low false positive rates as well. Comparison of real rule-based and modern systems comes with deep depending on strategic thresholds and high false alarm and poor adaptability to new fraud patterns. Combines relational and sequential learning, adaptive oversampling enhances minority fraud instance detection, delivers high AUC and improved F1 scores as well. The hybrid system continuously refines detection strategies using transaction history and entity relationships. And here the runtime scalability and deployment considerations comes with runtime analysis, optimization techniques, and deployment considerations. Explainability and auditing comes with attention visualization and node importance scores, and this impacts the enhancing transparency and trust in AI driven systems, facilitates fraud investigations and regularity audits. Key insights from performance visualization comes with high recall, high precision, ensures optimal reliability in live financial systems, reduces cost and analysis verification workloads. And coming to relevance and feature work directions is Agentic as a next generation solution, and the feature was comes with cross border and multi-currency analysis, explainable AI integration, continuous adoption as well. Summary of contributions comes with research introduced an Agentic AI based fraud detection framework that integrates graphical neural networks, GNNs, and transformer models, and DSORP. The key achievements comes with robust frauds, innovation of false positivity, real-time adjustments. Experimental results is summarized with these members. Feature extension, it could be used for cross-border multi-currency analysis, expandable AI, adaptive learning towards security and challenge enforcement. And this particular paper is being developed with respect to these following references. Thank you.